Okay, question number 9 here. So I'll give you that sine of theta is 12 over 13 and ask you to find the values of the remaining 5 trig functions. So the first thing that we want to do here is draw a triangle. I want to label the theta. I want to label the right angle. And then I want to fill in some sides. So I told you sine of theta is equal to 12 over 13. You should know that sine is opposite over hypotenuse. So that means I can let 12 be the opposite and 13 be the hypotenuse. So opposite of this is 12, and then the hypotenuse is the one that's across from the right angle. So that's 13. From there, I can call this x, and I need to solve for this side length. So I use Pythagorean theorem. X squared plus 12 squared equals 13 squared. This gives me x squared plus 144 equals 169. Subtract 144 from both sides. I get x squared equals 25. And then when I square root, that gives me x equals 5. Come over here. I can write 5. Now, this happens to be one of the special right triangles that has integer side lengths. So if you know that that's 5 and you don't need to go, and you just write the 5, you don't need to go through this Pythag process. So from here, I need to find the remaining side lengths, or sorry, the 5 remaining values. So let me go and switch to a smaller pen. This is opposite. This is hypotenuse. And this is adjacent in reference to that angle right there. So I already know sine. I'm going to find cosine of theta. I'm going to find tan of theta. I'm going to find secant of theta. Maybe I'll do the cosine first. Cosine is adjacent over hypotenuse. So I can take the adjacent side of 5 and write 5 and then divide it by the hypotenuse, which is 13. Same thing for tan. The tan is opposite over adjacent. We're all using SOHCAHTOA here, which I went over in some of the earlier videos. So tangent is opposite over adjacent. That gives me 5 over 12. Sorry, not 5 over 12, 12 over 5. Because I take the 12, which is opposite. Secant. Seek, ha, ha, ha. Secant is hypotenuse over adjacent. You can also think about it as 1 over cosine. So what's the hypotenuse? 13 over adjacent is 5. Cosecant of theta is equal to ho, ho, ho. Hypotenuse over opposite. That gives me 13 over, the opposite is 12. And then tangent of theta, I always say Ayo, is adjacent over opposite. See? Ayo, as opposed to Oa in this. So, not tangent, cotangent. So, what's adjacent? It's 5. What is opposite? It is 12. And then I have the 5 remaining trig functions, and we're done with this problem. Hopefully that helps.